today we're going to learn about linear and quadratic functions. Okay? So when we say linear and quadratic functions, we know that when we graph these, right, we're going to get functions. Meaning, it's going to pass the what test? Vertical line test. Right? So when we talk about linear and quadratic function, we know that linear means like lines, right? So we know all lines are functions except for what types of line? Vertical lines. So we know we're going to talk about these lines that are non-vertical. That's what we say. Okay, non-vertical lines. So we know these are functions. And quadratic functions. I don't know if you've ever heard of this before. Maybe some of you in intro, but this is a new kind of function that we haven't seen. It's not a linear function. So guess what? It's not going to be a line. It's going to be a curve. So today, for the first time, we're going to actually see a curve that is a function. Okay? And actually, you're going to, I think you might have seen this before. But anyway, so first of all, let me tell you this. Okay, so last time we learned a function is function f is defined by, if you look something like this, f of x equals to mx plus b. It's a linear function, right? And of course, m has to be some sort of a defined number, because if m is undefined, then you get a vertical line, right? So that's why we want to say something like this. It does not include any vertical line because we want m to be a defined number. Okay, it's got to be some number, right? Any real number. Okay. So we know this is a linear function. So this is, if you see a equation that has this form, f of x equals to mx plus b, we know it's a line. Okay, we know it's not a vertical line because it has to have some slope, right? Okay. M is some real number. Okay. So this is what we learned last time. Now I'm going to show you another form. Okay, another sort of form that will get you a function every time. Okay. So when you do a vertical line test, it's going to pass the vertical line test. It's going to be an equation, another function. I'm going to call it g because I used f already. A function g defined by this way is also another function, okay? And it's called a quadratic function. As I mentioned before, this will not be a line anymore. It's going to be a curve, okay? And notice I said a cannot equal to 0. I should write this down. So I'm showing you another function. This will get you another function that's not a line anymore, and it's called a quadratic function. Okay, so if you see an equation in this form, you know that it's going to be a function. Okay? As long as a isn't 0 in this case. Why do you think I said a can't be 0? So I should write this down, think about it. Some of you see it already? Okay, I should write this down, think about it. Why do you think this form, we want to make sure that a isn't 0? And ABC is some number, okay, some real number. Yeah, one person see it? 2 people? Why do you think that we have this thing called a can't be 0? Dominic? Yeah. Oh, did you want to add something to that, John?
Basically, I was saying that like you need some number squared because without the square it would be a linear equation.
Exactly. So I think you guys both correct. So look, you see how I have now for the first time x to the second power term, right? On the linear term, this was x to the what power? First. To make this a quadratic equation, you need x to the second power term there. Does that make sense? And if a is, of course, is 0, then that term goes away, and it just simply becomes a linear equation again. It kind of goes back to, right? Doesn't that become really this form, right? Instead of m, I would have b. Instead of b, I would have c. That's the only difference, right? So you have to have, you can't have a equals 0 because then you don't have a quadratic equation. Does that make sense? So this is a fact. If you have an equation that are in this form, we know we get a function. Is that okay? And so, don't you want to see what this function look like and so forth? Well, that's what we're going to work on. So let's take a look at what this function looks like. We said it's not going to be a line. Does anybody have any guess? Has anybody seen something like this? Okay, some of you. Okay, well, hold on to that. Wait. But let's see if your guess is correct. Okay. So, okay, some of you had some guess as to what this might look like. Alvin, what do you think? A parabola. How many people have heard of a parabola before? Good. We kind of mentioned this in intro, right? Yes, you are correct. You get a parabola. So the graph of this function, whereas the other one gave you a line, this one will get you a parabola. Okay. And of course, what does a parabola look like, by the way? Anybody remember? Aleph?
Does it look like a U?
Yeah, it's kind of looks like a U. It's not really a U, but yeah, you got the idea. So, so write this down. If A happens to be positive, the parabola would open upward, kind of like a smiley face. You could think about it that way. Guess what? So kind of like a U. But we'll talk about what it really looks like. What about if A is negative? Anybody have any guess as to what it might look like? E-Ray? Yeah, it'll be upside down. You get a sad face. Kind of think about positive smile and then negative, sad. So that's what you get. If A, that coefficient of the in front of x squared term, the quadratic term, by the way, that's what it's called. If that coefficient is positive, you get a the parabola that opens up, and if A is negative, you get a parabola that opens down. Okay, I'll show you that in a minute. Go ahead and write this down. Okay. Every time I ask this question, people ask, what if it opens, like, does it open on the side or so forth? If it did open on the side, would that be a function? Would it pass the vertical line test? No. So this is a function. So so you would either get that one opens upward and opens downward. The ones on the side you'll learn later. But for now, right now, we just only have ones that opens upward and downward. Okay? Don't worry about the one that comes on the side. Okay? Because that would not be a function. Right? To start with, it will not pass the vertical line test. Okay? Anybody need more time? Are you okay with this? All right, so let me show you how this. Remember that program that I showed you last time? This one here? I'm going to actually plug in a parabola. So I'm going to put an equation. And look what it says. Remember? It says y equals f of x. You see this one takes it as this equation in function form. Okay? So let's put that parabola, let's put that formula. What was the formula for the parabola again? General formula? A what? A times x squared. To the x squared, I could just type x twice because that's x times x, right? Ax squared plus what? Bx plus c. Okay, now if I do this right now, it'll be just a horizontal line. You see at that has us to 0. Let me make it thicker. You see this? The reason is because A, B, C are all 0 right now. Okay, so let me put some, because remember for a parabola we had to make sure that A cannot be what? 0. So let me change the value of A. As a matter of fact, let me take out the value of A, B, C, all of them out here. A, B, and then C. I like this program because you could change the value of A, B, C, those values, however you want to. So let me change A to 1. There we go. You see, we get a parabola, and we get a smiley face, as we expected, right? Because A is what? Positive. Guess what happens if I change A to negative 1? It's going to be sad face. It's called concave down mathematically, but it's okay. Sad face will work for now. So here we go. You get a sad face. You see that? It concaves down. The other is called concave up. Does that make sense? So that's what you get. See, look, I could change the value of A. I could make it automatically go. See, as the value of A goes from negative to positive, right? It changes. Kind of interesting happens though. Let me stop this. And look what happens if I change the value of A to like 3. You see how what's happening to this parabola? It gets narrower, doesn't it? Let's see if I change it to value of 10 maybe. You see how it got narrower, even more narrow. Okay. Do you see that? So I could go like, see, if it's like, if A is like 0.2, it's a lot wider, isn't that right? As we change the value of A more and more and more, right, it gets narrower and narrower. It works the same way. Like if it's negative 0.2, it's kind of wide, right? As I make this, it gets narrower and narrower. Okay, and it turns out this parabola, is expanding. So what I mean by that is, as the value of x increases more and more, it's getting wider and wider and wider. It doesn't kind of go back in. You know what I mean? It gets wider and wider and wider as the value of x increases, and then. Right? As you go from the right and to the left. You see how it's getting wider and wider and wider? Okay? So guess what your domain is? Domain, of course, in this is all real numbers, right? Guess what your range for this one will be? For in this particular one, it doesn't go any negative, right? So it's going to be all the positive values. Does that make sense? In this case, but it'll depend, okay, on what kind of parabolas you get. Okay. Yes.
How come the smaller the number, the not white? How come the smaller the number, the wider the parabola?
Okay. So the number, yes. So we'll learn this later. But I just want you to kind of be aware of that. As we increase the value of a, it gets a lot narrower, and as you could decrease it, it gets a little bit wider, and then of course, so on. Okay, but I just want you to be aware of it. Okay, but, okay, does that make sense? Okay, all right. I could change the value of b and c. Turns out c is that one number adding just one negative number, right? C turns out to be your y-intercept. See, if I change the value of c, it just goes up and down like this. Oh, okay, sorry. So c is simply the y-intercept. Tells you the y-intercept. Okay, and then if I change the value of b, it kind of makes it go to the left and right. Kind of does that. Because the c is fixed. Your y-intercept is fixed, right? Let's say y-intercept is 2, right? So what b does is it's just kind of, right, makes it go left and right. And because your y-intercept is always 2, right? B makes it go to the left and right of that. Does that make sense? It's kind of interesting to see. Yeah, and then a makes it like, you know, narrow, makes right, either smiley face or sad face, and then of course it makes it narrower as you increase the value of a. Okay. You could change the value of b, make it more, go this way more. Okay. Does that make sense? Pretty interesting, right? Okay, so that's what a parabola is. Okay. So depending on value of a, b, c, it'll change where it is. Okay. All right, here we go. On your homework tonight, it's going to ask you to graph this parabola. Okay, so we're going to show you how to graph this in a nice way, because unlike line, it's a curve. So you want to choose good points to graph. For example, so write this example. It says graph the function h this time, because we use f, we already use g. Let me use letter h. Graph the function h defined by h of x equals to x squared minus 6x plus 4. And of course, h of x, this function notation, is nothing more than just value of y. Isn't that right? So if I want to graph this, by the way, I know what this looks like, first of all. Look at my coefficient of the x squared. Is it positive? What is my a? 1. Very good. Is it positive or negative? Positive. So guess what we're going to get? It's going to be a smiley face, as we saw over here. Remember? When a was positive, right? We know we were going to get, right? It's going to be a smiley face. Open. It's going to open upward. If it was negative, remember? It was that face. So we know it's going to be, it's going to look something like this, okay? So that's what we're going to do. Now, how many points do you think, if I want to graph this parabola, how many points do you think we would need? For line, how many points did I say to use? Did I tell you to use? 3, right? I mean, you could use 2, but 3, right? To be more careful and so forth. So for a curve, do you think 3 points would be enough? No, it turns out I'm going to ask you to use 5 points. Is that okay? 5. So for your homework tonight, when I ask you to graph parabolas, please use 5 points. And you may ask, which 5 points do I need to use, right? Well, for now, I want you to use these points for this one. 0, 1, 2, 3. Actually, it turns out to be 6, but 5 would be fine. But let's just go from 0 to 4. Okay. So I want you to make a table. Remember, we know how to do a value tables of values, right? So for x, we're going to plug in 0, 1, 2, 3, 4. Let's go up to 5 since I have 5. And then plug in h of x equals to x squared plus 6x plus 4. And then, of course, the third column will get you an order pair, right? So I want you to all then try to plug in these values and give me the order pair. Let's do the first one together, okay? All right, who could help me how to do the first one? So let's plug in x equals 0. Okay. Who could help us how to do that? How about Elisa? What would you do to find the first order pair? Yep, that one is easy. What do you get? 4. So what is our order pair, class? We get 0, 4. Isn't that easy? Right? We got h of 0 equals to 4, so we get 0, 4, right? Can you do the rest? Can you do 1, 2, 3, 4, 5? Yes? Okay, go ahead. Everybody try. I'll wait for you, okay? Help each other out. That's fine, okay? I'll wait. See if you get the right ones. Actually, once you go up to 6, like how I have it here. So I know that I said we only need 5 points, but since it's our first one, we want to do this as carefully as possible. So let's go up to 6, okay? So we got 0 already. So you just need to do 6 more, okay? So 0 through 6, okay? Go ahead, everybody find the order pairs. And if you got it, verify with your neighbors, see if you have, with your groups, see if you have the right one, okay? Go ahead, everybody try. I'll wait, okay? So what did we get for 1? Did you all get -1 when you plug in 1? Yes? Okay. What about for 2, class? What did you guys get? Negative what? -4 is correct. What about for 3? What did you guys get for 3? Negative what? 5? Okay. What about 4? -4 again. Isn't that interesting? What about 5? -1. What about 6? 4. Okay. Do you know how to plot these points on a x and y axis? Go ahead and plot it and see what it looks like. Okay, go ahead, everybody try. Okay, did you all get this graph right here? This is what I got. And as we expected, right? We get a smiley face, kind of. By the way, do you think it's a good idea to draw V? Just kind of connect the dots. No, because remember we saw on this thing here, the parabola is not a V shape, right? It's a curve, okay? Please don't draw V, okay? Then you get it wrong. Does that make sense? So please do do your best to kind of go through all these points, right? And right, draw it like a nice curve. Is that okay? Is this easy? Can you do something like this for your homework tonight? But there's a trick on this. Actually, this one's kind of interesting because what if anybody see what might be the problem if I asked you this on the homework, right? If you just blindly plug in 0, 1, 2, 3, 4, 5, 6, it's not going to give you this sort of nice point. What do you think this is? In other words, imagine if the parabola, okay, if it was on the right side of this y-axis, it's nice. But what if the parabola was on this side, and you plug in 0, 1, 2, 3? What part of the parabola would you get? If you plug in 0, you would get 2, right? If you plug in 1, you get something like this way up here, right? Do you see what I'm trying to say? Yeah. So in other words, you have to know where the parabola will be, kind of. Do you see what I'm trying to say? Because imagine if you plugged in 0, 1, 2 blindly, you would only get the right side of the graph, right? You wouldn't know where it kind of dips up and down there. Is, by the way, the point right down here, this is called, anybody know what this point is called? This point is one of the important points. Write this down. You see the point, the lowest point? Or it could be the highest point. Because if it was the upside down parabola, right? So the lowest point or the highest point of the parabola is called the what? Anybody know? Vertex is correct. And please in order to graph the parabola correctly, you need to know where the vertex is. Otherwise, if you just blindly plug in 0, 1, 2, 3, 4, right? You may not even get to the vertex. Do you see what I'm trying to say? Yes? We have to know, you see how it's kind of symmetrical? You have to know the midpoint, vertex of the parabola. Okay, so I'm going to tell you how to find the vertex. There's a nice way of finding the vertex. Are you all ready? This is the key concept of the day. Because you have to find the vertex of the parabola first before you use a bunch of these points to plug in, right? What was our vertex in this parabola? It was 3 and -5, wasn't it? You have to know where the vertex of the parabola is, otherwise you can't graph. Are you ready to figure out how to figure out the vertex? Exactly. That's what I'm trying to show you. You could actually figure out the vertex without doing all these sort of work. Because once you know where the vertex is, all you have to do is what? let's say you found vertex, right? And we're gonna use 5 points. How many other points do you need on the right side of the vertex? 2 others. How many points do you need on the left side of the vertex? 2 others. That's what you're gonna need to graph. So let me show you how to find the vertex. You all ready? This is a key concept. And we'll figure out why this is true. To find the vertex, write this down. Fact. The coordinate, this is the key idea. If you don't know this, you cannot do your homework tonight. This is a fact. X coordinate of the vertex, you already know what it is? How did you know that? That's exactly right. It's negative b over 2a. Brandon is correct. So I could figure out by plugging in. By the way, what do you think this AB comes from? It comes from the quadratic equation, right? A is the coefficient of the x squared term. B is the coefficient of the linear term x. So this tells you the x coordinate of the vertex, and once you know, so for example, let's see if it works for this one. Negative b over 2a. Are you still writing it down? Okay, so write it down. And you may ask, well, where did you get that from? Well, later we'll explain that to you, okay? But for now, I want you to just know that that is the vertex, x coordinate. And this information is going to be really, really, really important, okay? So write that down, negative b over 2a. You have to memorize that, okay? All right, so let's see if it works for this one.
Why do you have 15 outside of the box?
Okay, that's not important. 15? Okay, that's not important. Okay, so negative b over 2a. So let's see if it works out. What was our a for this one, guys? Remember, a for this one was our previous example. What was our a? 1. What was our b? Is it 6 or negative 6? It is negative 6, isn't it? Because remember, this form should be ax squared plus bx plus c, right? So your b is negative 6. You see my coefficient right here in front of x, right? Isn't that negative 6? What's your c? 4. Okay, c is that y-intercept, so it hits the 4 there. Okay, so let's see if it works out. I want to know whether or not if we plug into that formula, our vertex, the x coordinate of the vertex, which is right here, I want to see whether it comes out to 3. Does that make sense? Let's plug it in. Negative b over 2a. So the x coordinate is negative b over 2a. Okay. So let's plug it in. X equals to negative, what did we plug in? Negative what? 6 over 2 times, what's our a? 1. What is negative over negative 6? That's positive 6 over 3, which is 3. Look, doesn't that give you the x coordinate? Yes. 6 over 2 is 3.
So you wrote 6 over 3.
Oh, yeah, wait, 6 over 2. Hello.
Oh, you added
Yeah, it's 2 times 1. I lied. What's 6 over 2, guys? 3. I was kind of worried about for a minute. Okay, so there you go. You get 6 over 2. So you get 3, right? Look, that tells you the x coordinate of the vertex has to be 3. Does that make sense? So when you do a table, you know that you got to start with 3 in the middle and what? 2 other points. What are 2 other points on the right side of 3? 4 and 5. What about the left side of 3? 2 and 1. So really, basically, you just needed to use 1, 2, 3, 4, 5. Right? If you didn't know that, right? You could be graphing just one part of the parabola that is not really important. I mean, not interesting, right? You will not get this nice points. Does this make sense? So when you do your homework tonight, you cannot just plug in any values like 0, 1, 2, 3, 4. You know what I mean? You have to find the vertex first, right? And then find the 2 other points on the right side of it and 2 other points on the left side of it. Do you see what I'm trying to say? Okay, because if you didn't, like, imagine, you could have just plot, like, the right side, this sort of part only, if you just plug in 0, 1, 2, 3. Do you see what I'm trying to say? Okay. So, I actually did it over here. Okay, so that's the x coordinate of the vertex. Are you okay with that? So that's how you're going to plot those. Easy enough? So let's do an example. What if it's the same one. Okay, so give me a sec. Let's do an example. What if I ask you to graph this one? Let's call it k of x. Oh, sorry. Here we go. K of x equals to 2x squared plus 4x plus 3. Now, when you do a table, we have to find our x coordinate of the vertex, right? X coordinate of the vertex first, because I don't know which values to plug in, right? So I need the middle one. So I need 1, 2, I need the x coordinate of the vertex, and then 2 other points the right side of it. So what was our formula again? Negative b over 2a. What is your a in this case? 2. What is your b? 4. What is your c? Okay, so let's plug it in. Negative something over 2 times something. Hopefully this time I won't make a mistake. What am I going to plug in for b? 4. What am I going to plug in for a? 2. So it comes out to negative 4 over 4. What is that? Negative 1. So I know that middle number has to be, this is the key, guys, negative 1. That's going to be my vertex, right? Because I want to get nice points. What are the 2 other points right side of it? Negative 1, and then what comes after? 0 and 1. What about negative 1? What are the other left side of negative 1? Negative 2 and negative 3, right? You wouldn't have picked these points at random, would you? Right? This tells you which points to plug in so that you get the order pairs. Do you see what I'm trying to say? If you don't do it this way, guess what? Your parabola, when you plug in just random points, you may just get right side of the parabola, left side of the parabola, right? It's not going to look really like a parabola, right? It's going to be like a sort of a part of a curve. You know what I mean? And so you have to include the vertex. This is where your vertex is going to be. Okay, does that make sense? Do you see what to do? So unlike lines, you cannot just choose any points you like. You have to choose the vertex in the middle and then 2 other points on the right side of it and 2 other points on the left. Okay, and we could figure out the order pairs and graph. Easy enough? Do you see what to do for tonight's homework? Now, on tonight's homework, it's going to ask you to do all the other ones. It's going to ask you to do like something that we haven't learned. Like they ask you to draw the axis of symmetry. They ask you to do all these. Don't worry about it. Just graph. Okay. All the other ones we haven't learned. Don't worry about it. Just graph using how many points? 5 points. Does that make sense? And one of the middle point has to be what? It has to be the vertex. Does that make sense? All right. Good.